So we're going to talk a little bit more about surjective functions. And this video is going to be a little shorter because we've already talked about surjective functions. Surjective just means onto. It means, do we cover the whole codomain? Is our range equal to the codomain, right? The range is always a subset of a codomain. The range is the set of all the outputs. The codomain is a set of all possible outputs. But when they're equal, we have a surjection. So we're going to start this with a definition of surjection. Now, you already have a definition of surjection, but let's step things up. Take a look at this definition. We're going to introduce a couple new concepts here. So f, which is a function that goes from some domain A to some codomain B, is onto, or surjection, if for all elements little b in big B. What did I just write? I don't know if you've seen this before. This is basically an upside down capital A, and it means for all. It's shorthand used in a lot of math proofs and logic. So we're going to introduce some some shorthand here. So it's onto if for every element in the codomain, if for every possible output, there exists, and yes, that is a backwards capital E. So we got another one. There's one more coming. This is good shorthand. You may or may not have seen it before. There exists an input. Okay, so there exists an input A in our domain such that, this is a backwards element sign. All right. So how is this definition going to finish, right? Because you know what surjection means. You know what onto means, right? It's for every possible output in the codomain, there's an input so that we cover that possible output. So it definitely should just be such that f of that input equals that possible output. Every possible output has an actual input that gets us there. Okay, so this is just, again, a fancy way of saying the range equals the codomain. Everything's covered in the codomain. We can get to anything in the codomain with this function. But we'll introduce a couple shorthands, and I'll try to use those more, get some practice. Love shorthand. Me personally, mathematicians in general, love shorthand. Oh, and again. All right, there we go. So, but hopefully nothing new. Let's do an example. So let's consider a function h, and this h has a domain from 1 to 3 and a codomain from 2 to 5. This is interval notation, inclusive. And I'm just going to show you the graph of h to make things a little easier on ourselves. And again, I actually could put graph paper out here, but I don't really like it. So we're just going to count 1, 2, 3, and then 1, 2, 3, 4, 5. And let's say this function starts at 1, 1, goes to 2, 5, and then stays constant. So it's a piecewise function, like so. And that's it, right? Because the domain is from 1 to 3. That's covered. The range is from 2 to 5. Well, let's make the range from 1 to 5 so I don't have to fix my graph that I graphed this function incorrectly. I graphed something outside of our codomain. That's not legal. All right. But anyway, here we go. Let's update that codomain to make my thing correct. I'm going to ask you a few questions for this. I want you to think about them. Is this surjective? Is this injective? And then a bonus one. So pause the video if you need to. Think about these. So surjective is onto, do we cover the whole codomain? So the codomain is the interval from 1 to 5. Are we achieving every y value in this interval from 1 to 5? And yes, we are. Every number in this is covered. Yeah. Yes, we are. All right, the range is 1 to 5. The range is the codomain. That's what we need. for a surjective function. For every output, for everything in the codomain, there's an input that will get us there. Pick anything in the codomain. Pick anything in the codomain. This is not a proof, but it's fun to play with. 2.7 is in the codomain. All right, 2.7 is right here. There's an input that'll get us there, and that input is about, I don't know, 1.3. Okay? For every output, for every possible output, there's an input that gets us there. That's another way of thinking about surjections. All right, and you could pick anything in this codomain. There's an input that'll get you there. That's what the formal definition of surjection means. For whether it's injective, well, is it one-to-one? Does it pass the horizontal line test? Injective means that every output that's the same means the input must be the same. Or again, if you have two different inputs, they must have different outputs. That's the contrapositive. Well, I have two inputs here. F2 and an input of 3 give us the same output. It's failing the injective test. This is not injective. Later on, we're going to use this information to say, that means it's not bijective. I'm spoiling it. I can't hold it back. Bijective just means, is it surjective and injective? Bijective is really exciting because, well, I won't tell you why bijective is really exciting. You're going to have to keep watching these videos. Whew. I'll keep that inside. We'll hold some secrets close to my chest. So now I want you to do is make a function. You get to create your own, build your own function. It's like Build-A-Bear, but a function, so much more fun. Make a function on this domain and codomain. So the same domain and codomain. That's flipped, basically. I want you to make a function that's injective and not surjective. All right, make something that is one-to-one, but is not onto. I'll put space for that over here. So pause the video, give yourself some time to think about it, play around with some stuff. Hopefully you get it. So again, it's going to have the same domain. It's going to have the same codomain. If we want it to be injective, it has to be one-to-one. And if we want it not to be surjective, it can't cover the whole range. Okay, so it needs to be one-to-one. A very boring example could be this. This is one-to-one, and it doesn't cover the whole codomain. The range of this is just 1 to 3. You could, make things a little bit more exciting. You could do like a piecewise function. You could do something like this. The important thing is that you make sure, you make sure it passes the horizontal line test. So however creative you want to be, just do something like that. All right, one more example and then we'll be done with this video. Let's make things, again, go to some multivariable functions. Consider G that goes from R cross R, remember that's the Cartesian product, to R. What does this mean? Remember, the Cartesian product of two sets means an ordered pair where the first ordered pair comes from the first set, the second ordered part of the ordered pair comes from the second set. So this is just an ordered pair of real numbers. That's all this is saying. The input is an ordered pair of real numbers. All right. With G of xy equaling x plus y over 2. All right. So my question to you, is this surjective and is this injective? So again, I want you to pause the video if you need to, spend some time and think about this. Is this onto is the range of this function equal to the codomain? Is the range of this function all real numbers? Can we get any real number we want as an output if we're plugging in any two real numbers? The answer is definitely. We don't have to know what this function looks like. Right? Any real number you can think of, we can get this. Here's an easy way to realize that. Here's an easy way to realize that. All right. So what if y was 0? If y were 0, then g of x comma 0 is just x over 2. We know exactly what that looks like, and we can get any real number we want out of that. So if we can get any real number out of y equaling 0, imagine how many real numbers we can get when y is whatever the heck we want. All right. And similarly, you could have done the same thing with x. So it's definitely surjective. Is it injective? Does every different input have a different output? No, this is badly failing this requirement, right? So it's not injective. Because, for example, g of 1 comma 2, that's equal to 3/2. That's also equal g of 2 comma 1. Uh-oh. Disaster. So, again, don't get this confused with sets. Remember, we said sets are not ordered pairs. Sets are not arrays. Sets, the order doesn't matter. Well, this is an ordered pair, and let me tell you something about ordered pairs you may or may not know. For ordered pairs, the order does matter. So these are not injective. Boo-hoo. If you graphed this, I should have planned for this. If you graph this, you're going to get a three-dimensional surface. You can visually see this as well. On a three-dimensional surface graph here, the surjection thing means that, yeah, we're going to cover everything on the z-axis. And the injective thing is if you drew a horizontal plane, a flat plane, it's not going to be injective because you're going to see that this plane intersects the graph infinitely many times. If we wanted it to be injective, it would only be able to intersect that horizontal plane once. All right. Injectivity is a much more interesting requirement for functions like this with 2 inputs. Anyway, that's it for this video. Let me know if you have any questions, and good luck.